Good evening, all of you. So, in day 26, we are going to discuss about stack and followed by different types of operations can be done on the stack. And after that, I explain algorithm for push operation, pop operation, and a peak operation. And after that, I explain the program. Stack can be implemented with help of a array. So now in day 27, we are going to discuss about another program on a stack. So the stack operations can be implemented by using a linked list. So this is a program for implementation of a linked list. So the linked list contain different types of nodes. So it is a single linked list. So it contain a data field and address of the next node. So it is a data field and the address of the next node. So initially the node name can be called as a temp node, and with help of a temp points to data is equal to address of x. We are going to read the value from the keyboard. So after that what you have to do? So we'll going to change temp as a top of the element. So why? Because the stack contain only one element in a stack. Okay, that's in the stack contain only one element, so that element is the top of the element. So that's why I'm going to change the temp as a top of the element. So later I will be added one more element, so that is a 35. So the name of this node name is temp. So temp points to data is equal to x. Then I want to read the x value from the keyboard, and after that what you have to do? So temp points to next is equal to this is the top of the value. So this is the top of the value, and after inserting this 35, now I'm going to pointing from 10 points to next is equal to top. So then it will connect it to the top of the element. So now after that what you have to do? You can change the top pointer as a, you can change the temp name as a top pointer. So why? Because now 35 is the top of the stack. And similarly I'm going to insert the 45 and so on. After that I'm going to delete the 45 from the top of the element, and after that I got only 35 and 20 will be there in the linked list. So this operations can be done on the stacks by using a linked list. Now I will go to explain the program. So I'm going to explain the program. So this is a program. So first one, I'm going to declare the structure. So in this example, the node contain only two fields. So that's why I'm writing here data field. So data field, so that is a 20. It is a data field, and address of the next node. So that is I'm going to write it as a struct node star next. So it contains only two fields. So that is a data field and address of the next node. So after that what you have to do? We have tried the initially top pointer is equal to null value. So this is operations. I can perform this track push operation, pop, display and exit, and you have to enter the choice. And for example, if your choice will be 1, so if your choice will be 1, so then I'm going to create a one node newly. I'm going to create a one new node, that is the node name is temp. So temp is equal to struct node star followed by mlx function. I'm going to allocate the memory for the temp node. So after allocating a memory for the temp node, so for example here I'm writing here. So I'm going to create a, so I'm going to create the nodes. For example here I will draw here the node contain two fields. So that is a data field and address of the next node, and then and the name of the node will be temp. So and by using a mlx function, I'm going to allocate the memory for the temporary node. So after that, what I have to do, I'm going to read the data from the keyboard. So that means I'm going to read the data field. So what is the data field? It contains all integer value. So now I'm going to read that integer value. So for that I'm using here scanf, enter the element, and I'm going to read address of x. So whatever the value you are going to read from the keyboard, that value will be going to store temp node, and in a data field you have to assign equal to x. So that means so this is a data field. So in this data field, I'm going to assign 10 points to data is equal to x. Then the 10 value will be stored in the place of data field. So after that, what do you do? So after that, what do you do? So 10 points to next is equal to top. So 10 points to next is equal to top. So in this example, I have only one node in my stack. Okay, I hope you'll be understanding what I'm saying. I have only one node in my linked list, so that's why this line is not going to execute it. So after that, what I have to do, I'm going to change the temp node as a top of the stack. So I'm going to change temp node. I'm going to change this temp node as a top of the stack. So why? Because it contains only one node in a linked list. So that's why I'm going to change the temp node as a top of the list. Now 10 is a top of the stack. So next one, now I'm going to create a one more node. So that is a temp node. So the name is a temp node, and by using a mlx function, I'm going to create the uh, memory for the temporary node, and after that I'm going to read a value, and whatever the value I'm going to read from the keyboard, that value will be stored in 10 points to data is equal to x. So this is a data field. So in this data field, I'm going to store, let us take, I'm going to read the data value from the keyboard is 20. So then the 20 will be stored in a data field. So next one, after that, what do you have to do? Now this line will go to execute. So now 10 points to next. So 10 points to next is equal to top. So this is a top of the stack. So 10 is a top of the stack. So now what do you have to do? So 10 points to next is equal to top of the stack. Okay, clear what I am saying? So just you can store the 10 points to next is equal to this is the top of the node. So now I'm going to connect it from 10 points to next to top of the element. So after that, what I have to do, I'm going to change this temp node as a top of the element. So now it is not a top of the element now. So 10 is not a top of the element. So after inserting a 20, now 20 is a top of the element. I hope you'll be understanding what I am saying. For example, if I want inserted one more node, so the node name is temp. So the node name is temp, and after that what you have to do, so temp points to data, so is equal to x. You can read the x value from the keyboard, and you can store temp points to data field. So after that what you have to do, now the second node is the top of the element in this stack. So now if you want connected from this node to this node, so what you have to do, so temp points to next is equal to top. So this is a temp node, so next equal to top, this is a top. So that means the address of the third node can be stored into the next node. So if you know the address of the next node, then it will be pointing from third node to second node. Now after that, what do you have to do? Now it is not a top of the element. So now the temp node is a top of the element. Okay, clear. Now 30 is the top of the stack. So and 10 is the bottom of the stack. I hope you will be understanding what I am saying. So that is a code for this is a code for creating a number of nodes with help of a linked list. And the second one, the case 2, that is a pop operation. So while popping of nodes, or while deleting a nodes from this stack, you need to check if top is equal to null or not. So if top is equal to null, then you have to display stack is empty. So I'm writing here, if top not equal to null, or if top equal to 0, then you have to print stack is empty. So if the stack is empty, you have to return immediately. So if the top value not equal to null, then you have to display you have to delete the top of the element. So for that what you have to do? So for that what you have to do? I'm writing here now this is the top of the element. So I want display. I want to delete this top of the value from the stack. So for that what you have to do? What is the code here? I'm writing. So top points to data. So the pop element is personally comma top points to data. So now it will go and display what is the top value 30. So after that, if after deleting this node, now I want move to second node. If you want moving from second node, then what is the code? Top is equal to top points to next. Top equal to top points to next. So then I will be moving from second node, and again I will go and display. I'm going to delete this 20 from this tag, and after that top equal to top points to next. Then I will be moved to the bottom of the element of this tag. Then after deleting this 10 also, then I got top equal to null. So whenever the top equal to null, it will go and display stack is empty. So that is the code for pop operation. And third one is display. So for displaying what you have to do, so I'm just to store the top of the value into temporary node. I'm going just to store the top of the value into one temporary node, and here I'm going to use a temp is equal to null. So that means that top is equal to null. So whenever the top is equal to null, you can write stack is empty and you can return. That means we are not going to display any elements from the stack. So that is the value. So after that what you have to do? So after that while temp not equal to null, so while temp not equal to null, that means if the top value not equal to null, now uh, you have to display the elements in the linked list, like by using a personally comma 10 points to data. So whatever the data will be there in the linked list, like 30, 20, 10. So that data you need to display. So for that I am writing 10 points to data. And if you want displaying a top of the data, and if you want move from next node, then you have to write temp equal to 10 points to next. So then like that it will go and display the number of elements in a given uh, stack. And fourth one is exit. So this is exit code. So if your choice is 4, then it will go to exit the program. So now I'm going to execute this code in the Turbo C++. So I'm going to execute this code in my Turbo C++. So can open the Turbo C++. So I'm going to close all the windows, and I'm going to open, and I will be looking for .c and stack linked list. So this is a program stack using a linked list. Now I'm going to compile the program by pressing Alt F9. So there is a one error, so that will be a parenthesis. So now you can save the program. So now you can compile the program. There is no errors in my code. Now you can execute the code by pressing Ctrl F9. So this here it will showing a menu item. Now I'm going to use a choice one, and I will be inserted 10, and choice 1 I inserted 20, choice 1 I inserted 30. Now let us display. So choice 3. So now here what is the top of the element? 30. So 30, 20 and 10. So 10 is the bottom of the element and 30 is the top of the uh, stack. So now we can pop by using a option 2. So now what is the pop element? The pop element is 30. And what are the left out elements in this stack? We can display once again. So the left out elements in the stack will be 20 and 30. Now if you want to delete next to top of the element 20, so the pop element is 20 and display. So now the stack contain only one element. If you are if you are deleted that 10 elements, and if you have to display once again, so it will be written, so it will be written to the program. Why? Because I deleted all the elements in a linked list, so that means the stack is empty. So whenever the stack is empty, then it will be written back to program. So that is the output of the uh, given example that will be implemented using a array, linked list, stack using linked list. So after deleting a 10, I got stack is empty. So if you have any, so now coming to next one. So what is the difference between arrays and stack? So in array, any element of an array can be accessed. So in array concepts, you can access any element in the given array with help of index number, and with help of index number, you can access any element in the given array. So whereas in a stack, we have to access only topmost element only. So we have to access only top of the element only. So after accessing a top of the element, then only you can access next element, and so on. So second one, an array essentially contain homogeneous elements. So the array is a collection of similar data items. So whereas a stack may contain diverse elements. So that means you can insert characters in this stack also. So instead of entering a numbers or integer values, you can also enter characters also. So that's why a stack may contain diverse elements. So next one, an array is a static data structures. So this is a very important. Array is a static data structures. That means the size remain constant. So what is the size we are going to mention at the time of compilation time? That size will be remain constant. You cannot increase or you cannot decrease the array size. So whereas in a stack, so the stack can be implemented by using a linked list also. That's why the linked list will be comes under dynamic data structures. So that's why a stack is a dynamic data structures. So that means you can reduce the size of the stack, or you can increase the size of the stack. So next one, there is an upper limit on size of the stack of the array, so which is specified during the declaration. So you can specify the number of elements in a array at the time of declaring of the arrays. Like you can specify maximum size of the array at the time of declaring of the arrays. So whereas in stack, so logically a stack can grow any size. So why? Because the stack is a dynamic data structures. So that's why it's not required to specify the size of this stack. So it will be grow, or it will be sync at any number of elements. So this is a difference between arrays and stacks. So if you have any doubts, please post your query in the chat box. So I will try to answer your queries. Now let us continue next one, applications. So what are the applications of stack? So the important applications of stack will be towers of an problem, and a reverse of a given string by using a stack, and recursion. You can solve the factorial of a given number or Fibonacci series by using a recursion using stack, and evaluation of arithmetic expressions. So these are the different applications can be done on a stacks. So this is one of the application, towers of an problem. So this is a game. So towers of an problem is a game. So that will be appeared in Europe in the 19th century, and this was invented by Edward Lucas. So it was invented by Edward Lucas in 1883. So here it contain a number of discs. It contain number of discs in increasing size from top to bottom. So uh, the top element is a smaller one, and the next top of the element is a little bit bigger one, and similarly bigger one like this. So it will be in increasing size of the top to bottom. And we have two more towers, tower 2 and tower 3. So by using a tower 2 and a tower 3, we are going to moving the disk from tower 1 to tower 2 and tower 2 tower 3, so that we'll going to transfer all the disk from tower 1 to tower 3. So with the help of a tower 2, we will going to transfer the disk into tower 3. So it is a initial stage of the towers of Anai problem. So here you have to follow some rules for moving a disk from tower 1 to tower 2 and tower 2 to tower 3. So what are the rules here? So only one disk can be moved at a time. So can move only one disk at a time from tower 1 to tower 2 and tower 2 to tower 3. So next one, only the top of the disk on any tower can be moved to any other towers. So you have to move only top of the tower, top of the disk only. You have to move only top of the disk from tower 1, tower 2 and tower 3. So it is not possible to move fourth disk or third disk from the tower 1. So we have to move only top of the disk. So after moving top of the disk, then only you can move to the second disk to tower 1, tower 2, tower 3 and so on. So next one, a large disk cannot be placed on a smaller disk. So one more important rule will be a larger disk. So for example, this is a small disk. So on that small disk, you are not going to place it on a larger disk. So that means that we'll be going to place smaller disk on larger one. So we'll going to place the smaller disk on larger one, but you cannot place larger disk on smaller disk. So these are the three rules. We have to follow these rules for solving of towers of Array problems. So this is the initial stage. So you have to move from only top of the disk from tower 1 to tower 2, tower and similarly tower 3. So then after solving number of iterations, then I got this final solution for the towers of Anai problem. So that is about the towers of Anai problem. And next one is a reversing of a given string. So with help of a stack, we will going to reverse the given string. So that means we can push the values into the stack. Like I want push characters S A I Sai. So now I is the top of the element. Now I'm going to pop this top of the element I. After that I'm going to pop next character A, and after that I'm going to pop next character S. Then I got the string will be in reverse order. So I'm going to insert this string as a Sai, and after performing a pop operation, then I got in reverse order. So with help of a string, we'll going to perform the string reverse operation. And similarly, with help of a stack, we'll also perform a recursion. Using factorial, or recursion using Fibonacci series and so on. And the fourth one is evaluation of arithmetic expressions. So for evaluating of arithmetic expression, you have to follow these notations like infix notation, prefix notation, and postfix notation. So what is the infix notation? What is the infix notation? So it contains operand and operator and operand. So that is the example is a plus b. So the original expression can be called as a infix expression. The original expression can be called as a infix expression. So next, what is a prefix operation? So operator. So I'm using operator plus. So after that, operand and operand. That is AB. So this is a original expression. So if it is a prefix expression, you have to write this symbol before the operands. So then the expression is called as a prefix expression. So next to postfix expression. So what is a postfix expression? Operand and operator. That is a B and followed by plus. So that means you can use a postfix expression. After operands, you can use a symbol operator. So this type of expression can be called as a postfix expression, and this type of expression can be called as a prefix expression, and this type of expression can be called as a infix expression. So the original expression can be called as a infix expression, and if you add plus operator before the operands, then it is called as a prefix expression, and if you add plus after the operands, then it is called as a postfix expression. So these are the different types of expression. You have to evaluate the expression arithmetic operations. So this is an infix expression. I said that if it is an infix expression, so the expression will be a plus b. So it is a like as a simple arithmetic expression. It is arithmetic expression. So the original expression can be called as a infix expression. So now we have to convert this original expression into prefix notation. So you have tried this expression as a prefix. What is a prefix? You have tried the operator, that is a plus symbol, after the before the operands. Then it is called as a prefix notation. So here the prefix notation can be also called as a Polish notation. So you have to remember these other names. So they may be asking in the gate examination or any competitive examinations. They will go and ask this type of questions. So the prefix expression can be also called as a Polish notation. And similarly postfix expression. And the postfix expression can be called as a reverse Polish notation. So that is RPN. RPN stands for reverse Polish notation. And prefix notation can be called as a Polish notation, and postfix notation can be called as a reverse Polish notation. And if it is a postfix notation, you have tried the operator after the operands. So this type of expression can be called as a postfix expression or postfix notation. So these are the three different types of notations: infix, prefix, and postfix. So now here I want converted from given expression into given expression into postfix expression. So what is a postfix? You have tried the operator after the operands. So this is an expression. Now I want convert this original expression, that is the infix expression, into postfix expression. So for that, what you have to do? You have to take a stack. So with help of a stack, we are going to convert it infix expression into postfix expression. So now I am going to take one table like this. So the first column, it contains character in the expression and the postfix. So what is the expression you want converted? You have to write here, and followed by stack. So what are the symbols you are going to place into the stack? You have to write in the third column. So for example, let us take first one. So it is a first character P. So it is a character P. So if it is a character, then you have to push into the postfix, or you have to write that character into the postfix. Okay, I hope you will be understanding what I am saying. If it is a character, you can place that character into the postfix. So next to plus. So next character is plus. So it is a symbol. It is a symbol, or it is an operator. If it is a symbol or if it is an operator, then you have to push into the stack. You have to push that operator into the stack. So next one, Q. So it is a character. Now you have to push that character into the postfix expression. So next one, by. So now I got by. So now I am going to use a by. It is a symbol. So that's why I need to push into the stack, or I am going to write into the stack. So now the stack contains two symbols, plus and division operator. So among these two symbols, division having a more higher precedence when compared to plus operator. So that's why I'm going to pop this division operator, and I'm going to add it to the postfix expression. I hope you'll be understanding what I am saying. So if the stack contain two operators, then you have to take which one having a higher precedence. You have to pop that operator and place it into the first fix. So in this example, plus and division, so division having a more precedence than the plus operator. That's why I'm going to remove division operator and I'm going to place it into the first fix. Then the first fix contain PQR and followed by slash. Or otherwise what you have to do, or otherwise what you have to do, I'm going to place one more character into the first fix. So after that I'm going to pop the division, after that I'm going to pop the division operator. Then I got the PQR by. So next minus. So it is a operator symbol or operator. Then you have placed into the stack. The stack contains plus and minus. Among plus and minus, plus having a next precedence. That's why I'm writing here plus. And now the stack contains only minus. So next character is S. So it is a character S. So if it is a character, you have to place it into the first fix. Then I got I'm going to insert the S after plus. So now the stack contain only minus value. Now you have to pop that minus and you have to place it into the after yes. Now after popping minus, now the stack is empty and there is no characters in the infix expression. Now this is a conversion of given infix expression into first fix expression. So PQR by plus S minus. So that is a conversion uh, from infix expression to first fix expression. So these type of questions will be asked in the competitive examinations like a GATE examination or other competitive examinations. This type of questions will be asked compulsory. And if you have any doubts here, conversion, for example, if it is a brackets, so if the expression contain brackets, what you have to do? So let us take again A. A is a character. You can post it in the, you can place into the post fix, and a star. Star is a stack operator. You can write into the stack. So next, left parenthesis. Now you have to write. It is a symbol. You have to write in stack. Next to B. So that will be right in first fix. Next to plus. That will be right in a stack plus, and C that will be right in first fix. So next to closing parenthesis. So if it is a closing parenthesis, what you have to, so what are the operators will be there up to closing parenthesis. So that operators will be going to remove from this stack. So now after removing a up to closing parenthesis, so it contains only one operator, that is plus. So I'm going to remove this plus and I'm going to add it to the first fix. So after that the stack contain only one operator, that is a star only. So now continue next one, star. Again I got star. Now I am going to place in this stack star and star. So if two operators will be there in the stack, we have to pop one operator and paste it in, and write into the first fix. And next character D. So now we have tried D into first fix, and if there is no characters, you can pop the next star from this stack. Now we have tried next star after D. Now the stack is empty. So like this you will go and convert the given infix expression into prefix as well as postfix also. So that is about applications of stacks. In the next class I will go and explain about queues. And if you have any, you can post your queries in the chat box. So that's all about today class. And if you have any doubts, please post the your queries in the chat box. So in the next class I will explain about queues concepts. So any doubts? So if you like this video, you can click on a thumbs up button, and as well as you can share, you can subscribe my channel. So if you are like this video, uh, or if you like this today lecture, so please subscribe my channel, and also you can click on a thumbs up button. So that's all about today class, and we will go to meet in the next day 28, and on that 28 we will go and discuss about queues concepts. So that's all about today class. Have a nice day. Thank you.